Lesson 6-3, Solving Systems Using Elimination. This is part 1 of Lesson 6-3. All right. What are two ways we've used to solve a system of equations? Well, in Lesson 6-1, we learned that if you just graph the two equations of a system and find the point of intersection, you can find the solution. In Lesson 6-2, we learned a method called substitution, where you solved an equation for a variable and substituted that value into the other equation to find your XY solution. Then, in this lesson, we're learning something new. It's called elimination. Sometimes, the way that systems are written, it makes eliminating a variable a good method to use. You might pick graphing, substituting, or eliminating. Once you know all three, it's up to you which one you want to choose. So here we go with elimination. All right, sometimes with elimination, we have to add, subtract, or multiply. In this video, we're going to focus on just adding or subtracting. Here's what I mean. All right, so in this problem, we have a system of equations. We've seen something like this before. Now we've graphed them and we know how to substitute. I'm going to teach you how to use elimination. If you look at the x values, the y values, and the constants, notice that sometimes when you have two equations, the coefficients of a variable will be opposite, meaning in the first equation I have a positive 5y, and in the second equation I have a negative 5y. If you ever line up your equations and you notice that a variable has coefficients that are opposite, you can eliminate them by adding. Let me show you. I'm going to rewrite my equations. 2x plus 5y equals 17, and 6x minus 5y equals negative 9. So now before you solve, if you're debating what method to use, look at your variables. If you see a coefficient, like we have in this case, a positive 5y and a negative 5y, if I add these equations together, watch what happens. 2x plus 6x equals 8x. 5y plus a negative 5y, 5 minus 5, that's 0y. Notice that I'm completely eliminating the y's from my system. Then 17 plus a negative 9 is also like 17 minus 9, 8. So I'm going to rewrite this without the 0. 8x equals 8. I've eliminated the y. All I do is divide by 8 to both sides, and I get x equals 1. I have just found the x value of our solution to this system. I just need the y. So take the x value just like you do in substitution, plug it into either equation. I'll take the first one. 2, instead of x, I'm writing our value of 1 plus 5y equals 17. 2 plus 5y equals 17. Subtract 2 from both sides. 5y equals 15. And when I divide by 5, I get y equals 3. There's our solution. So I added the equations together to eliminate the opposite coefficients of y. Let's do another example. Let's look at A. So when they give you two equations in a system, if you notice, actually, because these y's line up and we just did an example like that, let's look at B. You have two equations in a system. There's my constants. I'm looking at my y's, negative 3, negative 4. Nope, they're not opposites. Look at this. Negative 3x, positive 3x. Negative 3 and positive 3 are opposites, so I'm going to eliminate the x's. Let me rewrite my equations. Negative 3x minus 3y equals 9, and 3x minus 4y equals 5. Because they are opposite, I can add them together. Negative 3x plus 3x completely eliminates the x's from my system. Moving on. Negative 3 plus negative 4y, negative 7y, and 9 plus 5 is 14. Divide by negative 7, divide by negative 7, y equals negative 2. So negative 2 is the y value of my solution. I'm going to erase so I have room, because now I need to plug y equals negative 2 back into either one of the original equations. I'm going to choose the first one again. Negative 3x minus 3 times y is negative 2, equals 9. Negative 3x, negative 3 times negative 2 is positive 6. Minus 6, I get 3. Divide by negative 3, I get negative 1. X equals negative 1. There's my solution. All right, and the second example that we're going to teach you in this first part of lesson 6-3 is we're still eliminating, but this time we're going to subtract the equations. How you know to subtract is when you look at your equations and the coefficients of a variable are identical. In the last case, they were opposite, like negative 2 and positive 2. So when you see opposite coefficients, you can subtract, or sorry, not opposite, but identical, you can subtract the equations. 3x minus x is 2x. Negative 2y minus negative 2y. Negative 2 minus a negative 2 is like adding positive 2, which equals 0. The y's cancel out. 10 minus 6 is 4. Divide by 2, x equals 2. Then we plug x back into either equation. I'm going to choose the second one. 2 minus 2y equals 6. Subtract the 2. Divide by negative 2, I get negative 2. My solution is 2, negative 2. One more example. Look at your equations in the system. If you see a variable that has a coefficient, we can assume there's a 1 in front of these y's, and they're identical, they're both positive, subtract the equations. 4x minus x is 3x. Y minus y is 0y, they eliminate. 8 minus 5 is 3. X equals 1. Plug 1 back into the equation. I'm going to use the second one. 1 plus y equals 5. Minus the 1, y equals 4. My solution is 1, 4. Hopefully that started to make sense. I only have 2 problems for you to attempt. The first one you're going to solve by adding, the second one by subtracting. Bring your answers to class and please show all your work.